Hello everyone, this is Terry Palisch, Global Engineering Advisor at CARBO Ceramics, and I want to welcome you to another installment of our series entitled Results from the Field. Today we'll be talking a little bit about our SCALEGUARD, our Proppant-delivered scale inhibitor system, and its impact that it's had in a Uinta Basin case history. This is actually one of the very first installments of SCALEGUARD that we had back in 2014-2015, and we're going to be looking at some of the long-term results. So just a real quick recap on what SCALEGUARD technology is. SCALEGUARD is our proppant-delivered inhibitor system in which we take ceramic proppant grains and we purposely put interconnected porosity inside of it. That interconnected porosity is then infused with chemicals. In the case of SCALEGUARD, it's scale inhibitor. And then one of the key aspects, and we'll talk about it a little bit in a second as well, is the encapsulated or the controlled release membrane that we put on the outside of the grains. And what this does is it controls the release of the chemical, which is critical for this particular field study. And then, of course, one of the other advantages of the SCALEGUARD platform is the fact that it is a proppant. It substitutes a portion of the proppant, and it goes into your proppant pack, and it effectively inhibits from the fracture face all the way up through your production system. So again, just some of the highlights on how it's deployed. It replaces about many times less than 1% of the proppant pack. In the case of what we're going to be looking at today, it's 3 to 5%. In some cases, we've gone as high as 30 to 40%. It just really depends on the application. Again, it's an engineered design. We calculate the minimum inhibition concentration. We put together an elution profile. From there, we then are able to tell you how much water we'll be able to inhibit per pound of proppant. And again, always maintaining the proppant pack performance, the conductivity, the purpose for which you put proppant in your well to begin with. Ultimately, what this does is it allows you to save lease operating costs. These can be anywhere from surface injection to workovers, to pulling pumps, to scale inhibitor squeezes, but also it assures long-term production. A lot of times, many people don't even realize the kind of production they're losing because of scaling that may be going on at the sand face or the fracture face. And again, we've treated over 500 wells. These are some of the originals that I'm going to show you today. So let's move into the case history. There's really two fields, if you will, in which we are going to be talking about. The first is the Greater Monument Butte unit. That was documented in a paper. We're going to talk about that, and then the success there led us over to the Leland bench, and that's where we're going to look at some of the long-term results. So in the Greater Monument Butte area, this is a vertical well development. These wells have a very high scaling tendency. They tend to make high volumes of calcium carbonate and barium sulfate. It typically happens both because of natural scale formation with the produced waters, but also because they are using produced water as field water flood makeup water, and the mixing of the waters there also causes problems. It's not uncommon to have pumps scale up in a matter of days if you don't have a scale inhibition program in place. Now, typically this operator had been using liquid scale inhibitor in the fracture treatment itself, and then had actually moved into some particulate-based scale inhibitors. Unfortunately, in both cases, these were just very short-lived answers, and what they found themselves doing is they had to go back out and install annular injection and or just work over pumps periodically. Now again, most of this is all documented in the SP paper 173792, so I'll draw your attention to that for more details, but let me just give you a couple of the quick highlights out of the paper. So again, the key aspect here was the short-lived ability of the particulate diverters that they were using. And SCALEGUARD actually, in its history, prior to this application, did have a uncoated version. So originally SCALEGUARD was uncoated, and you can see when we look at an inhibitor profile versus pore volumes of water injected, you're without the coat, with the lack of coating, you had a very quick drop in scale inhibitor. You basically washed it all off early and wasted it. We made some chemical modifications that increased it a little bit, but the key was when we were able to put the semi-permeable membrane on. This allowed us to make that profile last much longer and inhibit much longer and save chemical early and turn it into inhibition late. So this is what was applied to the Greater Monument Butte design. This is why they were when they wanted to try it. So what I'm going to show you is the initial results of 5 wells. These wells were initially treated in 2014. Each of these vertical wells is 3 to 6 stages, anywhere from 200 to 400,000 pounds per well. The base product was a 2040 northern white sand, and then each one of the wells included anywhere from 5 to 7.5% of SCALEGUARD blend. So again, 5 to 7.5% of the 2040 northern white sand was substituted out, and in its place the SCALEGUARD was put in. And the target design here was the reason the volumes were chosen was the target was for a multi-year scale inhibition program. So we're not going to look at the results of all 5. I'm going to show you in a summary in a second, but I just want to show you one example because they looked almost all the same. So again, we're looking at inhibitor concentration versus barrels of water produced. Now in this particular case, they produced about 16 or 17,000 barrels of water. And just to put this in perspective, this is after about 200 days of production. But you can see the inhibitor concentrations drops off and was just running along here in about the 245 ppm level. Minimum inhibition concentration in this area is about 2. So again, after this 5, 6, 7 months, they had leveled out at about 4 or 5 ppm. Now, one of the things I also want to draw to your attention is this endpoint. So the red line represents the percent of inhibitor that's been produced. So we can integrate this line and determine how much inhibitor has been produced, or vice versa, how much is still left in the ground. So we've dropped down and we're rocking along here at about 4 ppm, and after 16,000 barrels of water, we've only produced about 1.5 to 2% of our scale inhibitor that we deployed. So we have a tremendous amount of field life or treatment life left in this particular well. Now we saw this on multiple wells, and what I'm going to do is just summarize them for you here. I know this is a busy chart, but again, 3 to 5, 6 stages per well. This is the amount of SCALEGUARD that was pumped total, which represented anywhere from 5 to 7.5%, just like we talked about before. Now, if we take each one of those plots like I just showed you, and we look at the endpoint, so in this case, 3 of the wells had produced 200 days, and 2 of the wells had produced for 165 days. And we look at those endpoints. At those endpoints, they produced this much water. So a couple of the wells had 15,000 plus barrels of water produced, and several others were much less than that. This is the residual level, so anywhere from 4 up to 50 parts per million. Of course, these wells hadn't produced as much, so their scale inhibitor level is going to be higher, but they also deployed more inhibitor. But this is the column I want to bring to your attention, because after this amount of time, anywhere from 160 to 200 days, again, they produced only anywhere from 1.5 to 5% of the scale inhibitor. So still a tremendous amount of inhibitor left in the ground to give us a long-term inhibition. So based on the successful results at the Greater Monument Butte unit, this operator then moved to another area called the Leland bench. In this particular area, the operator was again interested in inhibiting scale long-term. In this case, they took 9 wells. These 12 wells were treated in late 2014 or late 2015. And the idea here was going to be to compare it to offset wells in which the uncoated particulate inhibitor had been used. Now these were now more standard multi-stage horizontal wells. Each well was scheduled to take 2.3 million pounds proppant per well. The base proppant was 2040 white sand, and that 2.3 million pounds contained 3 to 5% of 2040 SCALEGUARD blend. Now, in this particular case, we moved to a polymeric base inhibitor, and I'll talk to you in just a moment about why we did that and why that's important. So what we're going to do now is look at the results from the area. The initial results, which is the first 8 months result, is shown in this part of the chart. So this is just a monthly average inhibitor returns in parts per million for the 9 wells. So you can see early on had some initial scale inhibitor returns like we would expect, then it quickly dropped down, again moved down to this just above the MIC of 2 parts per million, so running about 3 to 4 parts per million for the last 3 to 4 months, which again was looking very good. So you had over 90% of the inhibitor still available to inhibit into the future. We then went back to this operator last year, and we asked to get a couple of new samples just to see whether we were still measuring residuals after 4+ years of water production. Now this was out into the obviously longer term production and inhibition. Again, this operator was hoping for multi-year, so we wanted to just kind of do a look back and see how that was looking. And so what we're doing is I've cut the curve here now, so this is 4 years later, and we did do size exclusion chromatography on the scale inhibitor, a polymeric scale inhibitor. And this is important because we wanted to make sure that we weren't getting any impact if the operator on any of the wells, unbeknownst to us, had put on any topside injection or maybe done any scale squeezes. But by using the polymeric inhibitor and then this chromatography, we were able to identify just the scale inhibitor that we pumped. And as you can see, the good news is we're still seeing 4, 5, 6 parts per million. So still well above the MIC and still seeing good inhibition over 4 years later. Now you recall this operator also was looking at just trying to compare it to the particulate inhibitor they had pumped on some offset wells. This is the average in the offset wells. You can see that, again, because there's no coating on it or no membrane, you have pretty quick high wash off early in the life, such that by the time you get to about the 4-month period, the inhibitor has all been spent. So a tremendous amount of advantage by pumping the SCALEGUARD product from a longevity standpoint. So I'd like to just go ahead and summarize. Again, SCALEGUARD is our proppant-delivered scale inhibitor system that utilizes a porous ceramic proppant infused with scale inhibitor and then coated with a semi-permeable membrane. The Uinta Basin application, 2 fields, both are high scaling tendencies, treated 5 wells in the Greater Monument Butte and 9 wells in the Leland Bench. All showed great residual results just as expected for the first 6 to 8 months. In the Leland Bench, we went back and we sampled the wells, and after over 4 years of production, we're seeing residuals well above the minimum emission concentration. And again, no wells have been reported scale inhibitor issues to date. I would like to point out that this operator, since this time, after the results here, put SCALEGUARD in over 60 of their wells. So it's field proven across multiple basins, and these are just some of the many results we get with SCALEGUARD. And with that, I'm going to close. I do want to draw attention to our website, www.carboceramics.com, if you'd like more information on any of our CARBO technologies or about our strategy and field consultants or our Frac Pro software. Or if you'd like to go ahead and email me directly, I've put my email address on there for you. I'd be happy to answer any questions about this study or any of the other work that we've done. And with that, I want to wish everybody a great day.